In combinatorial mathematics, the Catalan numbers form a sequence of natural numbers that occur in various counting problems, often involving recursively defined objects. They are named for the Belgian mathematician Eugène Charles Catalan, 1814 to 1894. You could memorize that answer and say that you know what Catalan numbers are, but you really would have only learned a definition. You might be more interested in knowing what they represent or how you go about finding them. And that might lead you to wonder if you can find a really big one, like the millionth Catalan number, if it even exists. So many questions. But first, let's play an odd little game that might give you some insight into the Catalan numbers. This game uses strings of ones and zeros and has only two rules. First, strings must have equal numbers of ones and zeros. And second, no initial segment of a string has more zeros than ones. Starting with n equals 0, we have only one string. It's the string with length 0. There is nothing in the string. No zeros, no ones, no initial segments, and most importantly, it obeys all the rules. So if n equals 0, there's only one string, and that is the empty string. Next, n equals 1. These strings have length 2 times n, or 2. There are 4 possible strings, but only a 0 followed by a 1 or a 1 followed by a 0 have equal numbers of ones and zeros, satisfying rule 1. Of course, 1, 0 obeys rule 2, so for n equals 1, 1, 0 is the only valid string. For n equals 2, we're looking for strings of length 4, and there are 16 ways to make strings of ones and zeros that have length 4. But only 6 of these pass rule 1 with equal numbers of ones and zeros. We can also eliminate all strings that do not begin with 1 because of rule 2, which, if you remember, says that the strings can't have initial segments with more zeros than ones. This leaves 1100, 1010, and 1001 as options, but 1001 fails rule 2 because of the 0 in its next to last position. So for n equals 2, there are only 2 valid strings, 1100 and 1010. Now it's your turn for n equals 3. You're looking for strings of length 6 that satisfy rules 1 and 2. I've made up a verb called test3 that will tell you if you've found a valid string or provide hints if you haven't. I can tell you that there are 5 valid strings of length 6. Can you find them?